Hey everyone, today we are going to look at some ways to convert your model into the ONNX format so that you can leverage the awesome capabilities of ONNX Runtime. Let's take a look. ONNX supports and is compatible with many popular machine learning libraries to build neural networks. We are not going to go over how to do all of these. We're going to focus on the big ones like PyTorch, TensorFlow, and SciKit Learn. The first thing to consider when going to convert your model to ONNX is what is the training framework that you are using. And there's some different converters that you can go and download and use. So we have Keras to ONNX, TF to ONNX for TensorFlow, SciKit Learn to ONNX. And then for PyTorch, it's actually built right into PyTorch, which is super awesome with torch.onyx. So the first thing you need is to get the converter library that you need in order to convert your model to ONNX. So in this simple example from the pytorch.org docs, we're grabbing a pre-trained model, AlexNet, and we are going to then load that model. We're creating this dummy input, which is going to tell it the shape of my tensor and then also what device I'm using. Then I'm going to give it an input name and an output name. These input and output names are used when creating the ONNX model, and you'll need them later when you're going to use that model for inferencing with the ONNX runtime package. Once we've created these variables we need, all we have to do is call torch.onyx.export, send in the model, send in our dummy input to let it know the shape, give it a name, and then we're sending in our input names and our output names, and then it will output our model in an ONNX format, and then now we can leverage ONNX runtime. Now let's take a quick look at some of the parameters that you can send into the torch.onyx.export that was not actually used in that example. So obviously there are some parameters that are defaulted, but you might need to override those defaults, and let's talk a little bit about what those are. So this offset version is one, as you can see, it defaulted to 9. There are a lot of different versions, and I think this is an important thing to think about. In the docs, we have the operator schemas, and within here, you can take a look at what operators are supported in what versions. So if you run into an issue where you've converted the model and you're getting an error about the offset not being supported, you may want to take a look here and see which one will support your model. Now let's jump over to the ONNX runtime.ai docs and look at how we convert our TensorFlow models to ONNX. First, you need to pip install the TF to ONNX library, as we mentioned before. So the first way you can convert your model is directly in Python, and you can do this with Keras or with a TensorFlow model. And if you take a look, it's actually really simple, and it's going to look very familiar as to the way that we converted our model in PyTorch. So there's a lot of great consistency across the different tools for conversion. We're going to send in the model. We have created our input signature, which is our name, our type, and our tensor shape. And then we're sending in the offset that we want to use. Then we're grabbing that model and saving it to our path. Now, if you already have a saved model and you just want to convert that to TensorFlow, you can use the command line tool to convert the model. So we're calling tf to onyx.convert, and then we're calling the saved model, and we're going to give it the path to the model, and then where we want to output, and then also that offset version. If you're trying to convert a TF-Lite model, just add in the TF-Lite parameter. Again, as we mentioned earlier about the offset number, make sure you're using the largest one that's compatible. And if you try to convert with an offset version that isn't compatible with your model, you will get an error and they will let you know. And then you just want to go ahead and check out that GitHub list to see which one you need to use. Now let's jump over to the Huggingface docs and take a look at how you can convert transformer models to ONNX. So there is a transformers.onyx package. So again, it's built right in, makes it super easy. And this enables you to convert model checkpoints to an ONNX graph by leveraging configuration objects. So let's take a look at how we do this. Again, you're going to want to install the necessary package. We can see that in order to export any checkpoint, either one from the Huggingface or locally, what you're going to first do is give it the model name, and then you're going to give it the checkpoint that you want to create the ONNX model for, and then the path you want the output to go. Now, if we go back to the ONNX, we can take a look at the getting started. And here we have some examples on different ways to export for different machine learning problems. And if we scroll down, you can see we have one here for SciKit Learn. And here we are importing our convert sklearn from the SKL to Onyx. And then we're also importing this float tensor type. We are creating our initial type or our shape, and then we are going to use the convert to sklearn. We're going to send in our model that we created above here, and then the initial type. From there, we are going to give the model a name, and then we are going to write that to a file. So that was a quick introduction on how to convert your machine learning model into the ONNX format. And once you have your model in ONNX format, you can enjoy all the benefits of ONNX Runtime for inferencing, like the cross-platform deployments and the performance improvements. Be sure to stay tuned this March as we are doing a March Model Madness theme, and we are going to be posting some more fun videos about different innovative models that are using ONNX.